Hello my friends, welcome to the second lecture on quadratic equations and theory of equations. In this video, I will be explaining you the analysis of this quadratic expression and the derivation of Shridharacharya formula and some of its applications. My name is Yogeshwar Singh and let's start. First of all, I have already told you that a quadratic expression is something like this: ax square plus bx plus c. We have to convert this into a perfect square where this quadratic term and linear term involving the variable, that is x square and x, comes and combines into a perfect square. The remaining, as we all know, that a, b and c are constants over here, so whatever is remaining will be a constant number. So if we want to solve this, we will equate it to a number and then we can find the value of x. So what we do, the procedure is very simple and this is the easiest one. You make the coefficient of x square 1. You take out a common. Please don't remove a because it is not equal to 0. We cannot multiply both sides by 1 by a. So you have to keep this a till we equate it to something. After taking out a common, we get a times x square plus b by ax plus c by a. Now we have got a term a square. We need b square, so that if we use the formula a plus b whole square, a square is x square, b square is the number, and 2ab is this term. So a square is this term, 2ab is this term. So you have to make sure that this x is a and you will get a 2 and 1 term. What we do, we multiply by 2 and divide by 2. Now this term looks similar to 2 times a into b. So we have found out the value of b, that is a plus b whole square. We have x plus b by 2a whole square. But this b by 2a whole square, we need b by 2a whole square minus b by 2a whole square, because we cannot only add, we have to add and subtract both. Now if you see all this combined three terms, say a square plus b square plus 2ab, so we can combine this into a one perfect square, and that is called x plus b by 2a whole square. Whatever is remaining, c by a minus b by 2a whole square, you take minus sign common, it becomes b square by 4a square minus c by a. Take 4a square LCM, you get b square minus 4ac upon 4a square. This b square minus 4ac is a very important term. We will be discussing it now. Let's see. This b square minus 4ac is named as a discriminant. This term is so important in quadratic equations that it has been assigned a name. It is called the discriminant, d, which is equal to b square minus 4ac. Remember, BAC, that is these variables, these are not variables, these constants have specific meaning. A is the leading coefficient, B is the coefficient of x, and C is the constant term. You have to take this alphabets as it is. Now our expression becomes a into x plus b by 2a whole square minus d by 4a square. We have replaced this b square minus 4ac by d. Now you see, if we put root d whole square, then it becomes root d by 2a whole square. This relation converts into a times x plus b by 2a whole square minus root d by 2a whole square. A square minus b square formula. Apply the formula a square minus b square, you get a plus b into a minus b. So this is a minus b, that is x plus b by 2a minus root d by 2a, and x plus b by 2a plus root d by 2a. Thus we get a times, we take the LCM over here, we get a times x plus b minus root d upon 2a, x plus b plus root d upon 2a. Take minus sign common, we get a times x minus b plus root d upon 2a, x minus minus b minus root d upon 2a. You must be wondering why I am doing all this. You will understand very easily, because when we convert into an equation, then we get the values of x directly. For example, if we convert this into equation, we can say that either this factor will be 0 or this factor will be 0, because product of two numbers can be 0 only if one of them is at least 0. So either x minus this term is 0 or x minus this term is 0. From here you get the value of x is equal to minus b plus root d by 2a. Here x is equal to minus b minus root d by 2a. This, when combined, we called Shridharacharya formula. We name this root as alpha, we name this root as beta. These roots are the roots of the quadratic equation, that is minus b plus root b square minus 4ac upon 2a and minus b minus root d upon 2a. One root is named alpha, one root is named beta. It doesn't matter what name you are giving it to it. The most important thing is you have to remember this formula. This formula is called Shridharacharya formula or quadratic formula. You have to remember this formula throughout. Now let's move on to the second important thing. When you add these two roots alpha plus beta, you get minus b by a. This, after adding, you can very easily say this is negative over here, this is positive over here, these two gets cancelled, you get minus b, that is minus 2b by 2a. So from here we get that sum of roots of the quadratic is always equal to minus b by a. That is the coefficient of x divided by coefficient of x square, or the leading coefficient with a negative sign, that is alpha plus beta is always equal to minus b by a. So you can always calculate the sum of roots without actually solving the equations. Now let's go for product of the roots. When we multiply these two roots, you can name any root alpha, any root beta, you multiply it, you see a plus b, a minus b, means minus b minus some same thing, minus b plus same thing. So a plus b into a minus b is a square minus b square. You get minus b whole square minus root over b square minus 4ac whole square. The denominator becomes 2a whole square. So minus b square becomes b square. This root gets cancelled with this square. We get minus times b square minus 4ac whole divided by 4a square. B square gets cancelled. You are left with 4ac by 4a square or c by a. So do remember that the product of roots is always c by a, where c is the absolute term or the constant term in a quadratic divided by the leading coefficient or the coefficient of x square. Now there is one more concept which is not that much used, but still it's important. Here we'll find the difference of roots. Remember, there is a big difference between subtraction of roots and difference of roots. When we say difference of roots, it means we are trying to find the gap between one alpha and beta. Let's see it by an example. If you want to find the difference between 1 and 2, it doesn't mean that you have to find 1 minus 2 or 2 minus 1. Difference is 1. That is, there is a gap of 1 unit between 1 and 2. If you do 1 minus 2, you get minus 1 as the result. You 2 minus 1, you get 1 as the result. But the difference is the magnitude of 2 minus 1 or 1 minus 2, which will always be 1 unit. So when we calculate the difference, we ignore the sign of the difference. So we can say that it is alpha difference beta is mod of alpha minus beta. Now you put the values of alpha beta, it doesn't matter which one you are saying alpha, which one you are saying beta. You take the LCM 2a. Here you see that b gets cancelled and it becomes 2 root d by 2a. 2 gets cancelled. It's mod root d by a. always remember that if you want to remove mod from your equation or solution, you have to square it, because if the number is negative or positive on squaring, you will always get the positive number. So when we square alpha minus beta whole square, we get, now you can replace it by alpha minus beta. Alpha minus beta whole square is b square minus 4ac upon a square. So we have discussed sum of roots, product of roots and difference of roots. Remember these formulas. These formulas are very frequently and very importantly used. Now let's do some practice questions over here. I have given 5 questions for your practice. You can directly use the Shridharacharya formula, solve the questions. The answers are given right over here. This is direct application of the Shridharacharya formula, so I am not giving you the solutions. It's very well. Here I will just explain one. Here this equation is x square minus 5x plus 6. Value of a is 1, value of b is minus 5 and value of c is 6. You have to compare this equation with ax square plus bx plus c. Then you find the value of a, b and c and then put it in Shridharacharya formula. You will get the answers. Now let's do some good questions. If you are given one root of quadratic ax square plus bx plus c is 3 times the other, one root of this quadratic is 3 times the other, then you have to find a relation between a, b and c. I suggest you pause the video, try the question on your own and then you can see the solution. For solving this question, it is given that one root is 3 times the other root. Means if we say that one root is alpha, then the other root will be 3 alpha. We have to find a relation between a, b and c. It means we don't need alpha or x. We need only a, b, c. So we find this alpha in terms of a, b and c. Alpha plus 3 alpha, that is 4 alpha, is equal to sum of roots. This is sum of roots equal to minus b by a. So 4 alpha is equal to minus b by a. From here we get the value of alpha. Alpha is equal to minus b by 4a. Say it a relation 1. We know one more relation, that product of roots is equal to c by a. So alpha into 3 alpha is c by a, or alpha square is equal to c by 3a. Now if you replace the value of alpha from relation 1 into this equation, you will get a relation between a, b and c only. This is your answer. You can simplify it. So if you put alpha is equal to minus b by a over 4a over here, you get b square by 16a square should be equal to c by 3a. Cross multiply, you get 3b square is equal to 16ac. This is your answer. Now let's do one more question and this will help you develop the concept of quadratic equations. First, the second question is, if one root of ax square plus bx plus c is square of the other and a square c plus ac square minus lambda abc plus b cube is equal to 0, then you have to find the value of lambda. You already know Shridharacharya formula. You know sum of roots is minus b by a. You know product of roots is c by a, and you know difference of roots is root d by a. But you have to use all this in this equation and solve the question. Once again, pause the video, try the question and see the solution. For solution, we again assume the first root as alpha and the second root as alpha square, because it is given that one root is square of the other. So you get alpha plus alpha square, that is sum of roots is minus b by a, and alpha into alpha square is c by a, that is product of roots. You need a square c, ac square, lambda ac, abc plus b cube. See, you don't see any cubes or higher powers in this relations. You see every term involved in this equation is of degree 3. Here degree is 3, degree is 3, 3, 3. Here you have almost 0 degrees. So what we say, you make this equation of degree 3. You cubed relation 1. After cubing relation 1, you will get alpha plus alpha square whole cube is equal to minus b cube by a cube. A plus b whole cube formula is a cube plus b cube plus 3ab into a plus b, which results in alpha cube, alpha to the power 6, 3 times alpha cube into alpha plus alpha square is equal to minus b cube by a cube. Alpha cube we already know, it is c by a. So we put the value of alpha cube as c by a plus c square by a square, because this is alpha cube whole square, 3 times c by a, and alpha plus alpha square is minus b by a. Again use this relation and put it over here. You get 3c by a into minus b by a is equal to minus b cube by a cube. You got b cube. What do? You cross multiply with a cube. You get a square c plus ac square minus 3abc plus b cube is equal to 0. Here you observe that this relation which we got is almost similar to the relation given in the question. Only thing missing is this lambda, and when you compare this relation with this equation, you get that lambda should be equal to 3. So you get the value of lambda as 3. This is your answer. Thank you for watching. Remember, practice makes a man perfect, and there is no substitute for hard work. Please do subscribe to my channel. Thank you very much.